Hello class, we're on our last section for chapter 5, and the last thing that we have done up to chapter 5 is how to graph equations like y equals mx plus b, right? So this one, today we're going to do inequalities, and it's going to be the same idea. Y is greater than or less than or greater than or equal to or less than or equal to mx plus b. It's the same thing. You're going to be using slope, you're going to be using the y-intercept, just as we did in chapter 4. Now, the only thing that will be different is how the line will look, and there's actually going to be a type of shading, okay? The line is called the boundary. This divides your coordinate plane into two half planes, okay? So the line is called the boundary, and then we have to decide what part of the solution is included, and which is the solution is a closed half plane, or how do we show when it is not included when it's an open half plane. And so there's all these different ways of, when you have greater than or when you have greater than or equal to. How can you show the difference there? Or how can you show the difference between a greater than and a less than? How do you show that? So there's going to be different types of shading. So you do have to remember the skills of doing slope-intercept form. If you read the steps here, I'll just read through the steps. It's kind of the same as slope-intercept form, so you do have to make sure you have that good foundation. All right. So the first one is make sure the equation is slope-intercept form. This is another word of saying just get y by itself. Now, steps 2 and 3 is an if statement, whichever case that you have. So if you have y is less than or y is greater than, you are going to use a dashed line to show the boundary line, right? Now, when we had less than before, it was an open circle. So since obviously we're not going to be doing circles, it's going to be some sort of line, we're going to use a dashed line. Now, if the y is included, meaning less than or equal to or greater than or equal to, then we're going to use a solid line. Maybe I'll circle this one in blue, a solid line. And then number 4 is use a test point to determine which half plane is included, meaning which point would fit in your inequality. So a really good one to use is 0, 0, unless if the line passes through the origin. Then you'll probably have to pick another one. And then the last step is shade the half that contains the solution. Now the shading part could be a little bit challenging because a lot of people get confused. It's not a left or right thing, it is above or below thing. Alright, so let's continue on with the notes on our next part. So we're just going to go straight into an example here, and we're just going to go step by step with what we said. So we have y is greater than 1/2 x plus 3. Now the first step was to make sure y is by itself. Indeed, right now, in example A, y is by itself. So we're good to go. Step 2 or 3 was an if statement. Now this is y is strictly greater than. So this means that we are going to have a dotted line. Dotted line. So when we do our slope, it's going to be a dotted line. So and let's just do everything normally. Now here's my y-intercept. This is my y-intercept, and this is my slope. So if I just go ahead and graph this, my y-intercept is 3, so then I look for the 3 on the y-axis, and my slope is +1 over +2, which means I'm going up 1 to the right 2. So if I go up 1 to the right 2, there's my next point. And then I'm just going to draw a line through those two. Now, it can't just be any line, because step 2 said that since it is strictly greater than, it has to be a dotted line. So my dotted line is going to go through these 2 points. I'll just start. There's my dotted. There's my dotted line. I'm just going to draw arrows to signify that this dotted line goes on forever. And so there's our slope. There's our equation. Y is greater than 1/2 x plus 3. Now the next thing is we're not done yet, unfortunately, because now we've shown that it's strictly greater than, right? But how can we show that there's a solution greater than 1/2 x plus 3? Now here's where it can get a little bit tricky. Greater than means it's going to be above the graph. And so the way I like to think about it is the line that we just drew is like a roof of a house, right? For this one, it's the left side of the house. So if we're looking at the left side of the house, right, if I were to draw you a house like that, there's my roof, okay? So we're looking at the left side here. I'll highlight the left one in blue. So we're looking at the left side. That's what our roof looks like. Now we are going to shade above the roof because it is greater than, if that makes sense. So my shading is going to be above this line. And then that's it. And now we're done. So let me just recap the steps here. Okay, I know it can be a little bit confusing, but let me just kind of recap. So we make sure y is by itself. We graph it the same exact way, mx plus b, use the b as the y-intercept, so the 3, and then we go up 1 space to the right, 2 spaces for our slope, and since it was strictly greater than, we knew our line was going to be a dotted line. And once we did that, we determined, okay, the y is going to be greater than the 1/2 x plus 3, and greater than means it's going to be shaded above the roof, above that line. So I like to think about it as if it's greater than, it's raining on top of the roof. Okay? So if you understand that, you can try to move on to B. If you'd like to, you could try it on your own, pause, and then try it on your own, and then I'll kind of lead us through it just to make sure that you understand. So the first thing I did was subtract 1 on each side, because the first step is we got to get y by itself. And so when I did that, I have x minus 1 is greater than or equal to y. Now, this is a true statement. I usually like to deal with y on the left side, so if you want to do that, you just got to make sure you flip the inequality. So the same exact statement is just y is less than or equal to x minus 1. Now I'm going to graph it the same exact way. My b is -1, and my slope here is 1x, which is just 1 over 1. Maybe writing that on the side will help you. So if my b is -1, I'm going to go to my y-axis, plot a point on -1 here, and my slope is a +1 going up 1 to the right 1, and there is my next point. If you want to keep going, you could definitely keep going. Now, we have y is less than or equal to, so instead of a dotted line here, we're actually going to have a solid line. There's the solid line. Again, it is solid because it is less than or equal to, and again, like before, we don't have open circles and closed circles, but instead of that, what we replace that with is dotted lines and solid lines. And so that's what we got to take care of. Now, y is less than or equal to the expression x minus 1. So again, if I draw my house, the green line that we drew is, again, the left side of the house right here. But since it is less than, it's actually going to be under the roof. It's going to be under the roof and inside the house. So I guess it's, in a sense, kind of raining inside the house. So I'm going to just shade everything under the roof. So all of those shadings means any point in that shade is a possible solution, and anything that's not shaded is not a solution. So you can actually go ahead and test. Let's say we wanted to see what about this point right here, 4, -2, 4, -2. If you plug that into your inequality, then you would have -2 is less than or equal to 4 minus 1, and -2 is less than or equal to 3. Now that's obviously, again, that's very true. But if we picked, let me pick an orange color. If we picked, let's say, -2, +3, -2, +3, and we plug those into the correct variables. So if you did 3 is less than or equal to -2 minus 1, you'll realize that that statement is false. And so that's why this doesn't work. So the points on the outside of that are not working, but any of the points that are part of the shading is a possible solution for this. If you understand this, then you can move on to the next page. If you still feel like you need to go back to example A or example B to understand the shading and the steps and whatnot, or you want to practice a little bit more, pause or rewind and just take some time to do that. Now you can actually even use a coordinate plane just to solve inequality with one variable. So if we get our variable by itself, like here, you'll notice that there is no y, right? But it still can be an inequality. So if you just kind of solve for the x by adding by 3 and divide by 4, we get this inequality that x is greater than or equal to 5. Now normally, when we have that, we would usually think of a number line and think 4, 5, 6, 4, 5, 6, and this was an open circle, or I'm sorry, closed circle, and since it's greater than, you shade it to the right. No. But when we're dealing with an xy coordinate, how do we graph x is greater than or equal to 5? Now, if we remember from chapter 4 and a little bit even before that, when you have x equals a number, this was a vertical line, right? And y equals a number was a horizontal line. So that's kind of coming back here. And so when I give you what on the test, like a coordinate plane, and then you end up like this with just one variable, you got to remember the vertical and the horizontal lines. So since x is greater than or equal to 5, that tells me I'm looking at the number 5 on the x-axis. So here's number 5 on the x-axis, and it is going to be a vertical line. Now you have to ask yourself the same questions. Is it going to be a dotted line or a solid line? And so since it's equal to, it's going to be a solid line. And since it's going to be a solid line, now the last thing is, where do we shade it? So this one, the roof analogy doesn't really work, but you kind of have to use your logic. What are areas where your x values are greater than or equal to 5? Greater than or equal to, if we're looking, it's going to the right, so that's why our shading will make sense to be on the right side. So x is greater than or equal to 5 is all the possible solutions that go to the right of that vertical line. Horizontal lines will be the same thing. If it's greater than or equal to, then it will be above the line. If it's less than or equal to, then it will be below the line. And so a vertical line greater than is to the right of it, less than is to the left of it. If you understand that, go on, scroll down to the next page, or I'm sorry, to the rest of the page, and then we'll do a real-world example and kind of make a graph from that. Otherwise, you can kind of pause, rewind if you need to, and then just watch again. It says here, a yearbook company promises to give the junior class a picnic if they spend at least $28,000 on yearbooks and class rings. Each yearbook costs $35, and each class ring costs $140. How many yearbooks and class rings must the junior class buy to get their picnic? And so we have a let statement here. It says, let x equal the number of yearbooks and let y equal the number of rings. And so I want you to take a few seconds, pause for a little bit, and write on your notes what do you think would be the inequality that would be appropriate for this situation. So with each variable, you'll recognize that each of them has a cost. Each yearbook costs $35, right? So yearbook and $35. So x and the 35 will have 35 times x, and that will tell us how much they'll profit from how many yearbooks are sold. So if they only bought 2 yearbooks, then it would cost $70. If they bought 10 yearbooks, then it would be $350, right? And so on and so forth. So depending on what the letter x is. And also, since we want the sum of that for the number of rings, which is $140 rings, 140y, so we have the total now of the yearbooks plus the class rings. Now it has to be at least $28,000, meaning 28,000 has to be the smallest number, and so we have $28,000 at least. And so we have here So let's start graphing it. I'm trying to figure out how we can answer this question, but for now, let's start graphing it. And first things first, we got to make sure, right now it's in standard form, and we got to get it into slope-intercept form, so we have to solve for y. So why don't you pause for a sec, take a few seconds to do that. When you get y by itself, you'll actually realize that after getting dividing and stuff, the slope you get is -1/4x plus 200. You get y is greater than or equal to that expression. And so if we want to graph it, you'd have to look for the y-intercept and then go with the slope. So let's look for our y-intercept first. Actually, let's label the graph first here. So for each side, the x-axis and the y-axis, I labeled every other line by 20s, so I guess each line represents 10. Now, if my y-intercept is 200, then I'm going to put a point up here at 200 on the y-axis, and I'm going down one space and to the right 4 spaces. So down 1, to the right 1, 2, 3, 4 spaces, and I can just keep going down 1 to the right 4, 1, 2, 3, 4 spaces, down 1 to the right 4, and so you'll see that there's a trend that's going down 1 to the right 4 and down 1 to the right 4. And so there is there's what we can see. So there's a lot of possible solutions that you can have, okay? And so now y is greater than or equal to, since it's equal to, we're going to include that, so we're just going to have a solid line just kind of going across each of these points as best we can, and so we're going to have a solid line, and y is greater than this, and so if we have our house analogy, since it's greater than, we're on the right side of the house here, it's greater than, and so it's going to be shaded above that, and so we're going to have a shading above these. So any of the points above these things is where it can work. Now, the question says, how many yearbooks and class rings must the junior class buy to get their picnic? I was kind of thinking about this question because there's lots of possibilities. You could sell 0 yearbooks but 200 rings, and you could still make it, right? That point right here, 0, 200. This point right here, 40, 190. This is 40, 190. This means that you could sell 40 yearbooks and 190 class rings, and they would be able to have a picnic. Or if you go to the next point here, you could sell 80 yearbooks, and 180. I'm sorry. Yeah, 80 yearbooks and 180 rings, then yeah, you could sell the picnic. And those are the bare minimums there. Or you could pick a point anywhere on top, and they would for sure have a picnic from the yearbook company. That might have been a little bit confusing. If you need to read through that or watch through that again, pause, rewind. Otherwise, we can talk about it when you come back on the next school day, and you can ask questions to get ready for your upcoming test.